Good day, students. Welcome to part one of the AP Calculus AB multiple choice release questions for 1998. In this installment, we're going to be going over questions 1 through 5. All right, so let's take a look at question number 1. It says, what is the x-coordinate of the point of inflection of the graph y equals 1/3 x cubed plus 5x squared plus 24? Before I start, just a real quick note, this document I'm using right here, you can find it on math.serve.com. You can just go to my website /testprep and then you can download a copy of this document, okay? So in order to find the point of inflection, all you have to do for number 1, let's write down some notes, to find uh, point of inflection, find the point of inflection. If we're doing it algebraically, okay, you want to find a point of inflection algebraically, all you simply do is you solve the equation y double prime equals 0, okay? So if you can find a function that represents the second derivative, you set it to 0 and solve the x values that satisfy that equation will be the x coordinates of the point of inflection, okay? All right, so in this question, we're provided with the function y equals 1/3 x to the third plus 5x squared plus 24. So in order to find the equation that we can use to solve for the point of inflection, we have to differentiate this function twice, okay? So let's find the first derivative, y prime. We're going to be using the power rule. So it's going to be 3 times 1/3 x to the 3 minus 1. Using the power rule there, power rule for this term by term differentiation, okay? So 2 times 5, x to the 2 minus 1. And we know the derivative of a constant is 0, all right? So let's simplify this, and then we're going to differentiate it again, all right? So y prime equals, this 3 divide out, x squared plus 2 times 5 is 10, 10x, and then this is 0 drops off, all right? So to find the second derivative, we differentiate again using the power rule. So this will become 2x, 2x to 2 minus 1, which is just 1, plus the derivative of 10x is just 10, okay? All right, so this function, when we set it equal to 0, it will tell us the point of inflection, all right? So we set 2x plus 10 equal to 0. Solve this, subtract 10 from both sides. We have 2x equals negative 10. Divide both sides by 2. We'll have x equals negative 5. So you have to be really careful with your signs here, because you notice we have positive and negative values, signs of the same value here, okay? So be careful with your signs. Our answer for option number 1 is letter D. Okay, so now let's move on to number 2. All right, so for number 2, we are asked, we're given a graph of a function, a piecewise defined function. Where you go? Okay, there you are. We're given a graph of a piecewise defined function, and we're told that the graph of a piecewise linear function of f from -1 to 4 is shown above. What is the value of the integral, the definite integral from -1 to 4 of f of x dx, okay? So what on earth does that mean? What is the integral, the definite integral of f from -1 to 1? That basically represents, if this is the function f, right here, if this is f, then that integral expression that we're provided represents this integral right here. Integral from -1 to 4 of f of x dx represents the area between the curve and the x-axis for the entire domain, okay? So let me just illustrate what it is to you real quick. So this expression is this whole piece right here and this piece right here, okay? That's what this integral represents. All right, so if you examine this this function, we can divide it into 2 distinct shapes, okay? So this is the first one, this is the second one down here. What kind of shapes are these? These are trapezoids, right? So we don't actually have to use calculus to solve this problem. We can use elementary geometry to figure this out. So let's call this trapezoid 1, T1. You know, let's call this trapezoid 2. All right? Do you remember the formula for the area of a trapezoid? Now, it's critical that you know the formula for that, you know, for the trapezoid rule and other problems on the integration. All right, so let's go over that real quick. Area of a trapezoid, a trap, is given by 1/2 of the sum of the parallel sides, b1 plus b2, parallel bases, times the perpendicular height to the 2 bases, okay? All right, so let's look at T1. So for T1, this is the first base, b1 of t1, okay? And this is b2 base 2 of t1, all right? And then this perpendicular height right here from this point all the way down here, that's not a straight line. Let me use a straight dotted line so that we don't get confused. This height right here, that is the height of trapezoid 1, okay? So this is, let's call it h1. And in this trapezoid right here, this piece is, let me change my color so we don't get confused, the screen. This piece right here, this is base 1 of trapezoid 2, okay? And this piece right here is base 2 of trapezoid 2. And this height right here is height of trapezoid 2h2, okay? So this integral that we're looking for, we can break it up into two integrals. We can break it up as the integral from -1 to 2 of f of x dx. This represents the integral, I mean the area of trapezoid 1, right? The area under the curve when the function is above the x-axis, plus the second one is going to go from 2 to 4 f of x dx. This represents t2, or the area of the function where the function is underneath the x-axis, all right? So there goes the respective integrals. So these integrals are basically the areas here, so we can rewrite this as the area of trapezoid 1 plus the area of trapezoid 2. If we can compute these two areas using this formula, then that will tell us what the value of the integral is, all right? Okay, so let's go ahead and apply that. I'm going to shift this down a little bit. All right, we're going to apply the formula twice. So let's take a look at trapezoid 1 first. So for trapezoid 1, we have 1/2. The base of trapezoid 1, the first base is 1, going from 0 to 1. This length right here is 1, plus the base of trapezoid 2 is this entire length right here, 1, 2, 3, 3 units, so plus 3. And then what's the height of trapezoid 1? It's this height right here, h1, which goes 1, 2, 2 units. So 1/2 plus 1 plus 3 times 2. That's the area of trapezoid 1. Area of trapezoid 2, we're going to use the same formula, 1/2. Base 1 of trapezoid 2 is this length right here, which is 1, 2, 2 units in all. And then for base 2 of trapezoid 2 is this length right here. From 3 to 4 is just 1 unit. So this is 1 right here. Okay? Alright, and then what is the height? This length right here from -1 to 1 is just 1 unit. Actually, we're going downstairs, so it's going to be -1. Alright? So the height is going to be -1 minus 1. Alright, so there you have it. So if we compute this, that should tell us what the answer is. Okay, so let's go ahead and do this arithmetic real quick. So this is going to be 1/2. 1 plus 3 is 4, but times 2 is 8, times 8 plus 1/2. 2 plus 1 is 3 times -3. Okay, so this is going to be 1/2 of 8 is 4 minus 3/2. 4 minus 3/2. We can, the same thing as 8 over 2 minus 3 over 2 when we find the LCD, which is 5 over 2. And in decimal form, it's 2.5. All right. So we can clearly see that our answer here is option letter B. Okay. So there you have it. So just remember that this entire expression right here is the integral from -1 to 2 of f of x dx. This region, this entire region down here, that's what it is. Okay. And then this region down here, this one, is the integral from 2 to 4 of f of x dx. Okay, this entire region down here. And this is basically the area of trapezoid 2. And then up here, this is the area of trapezoid 1. Okay? Alright, now let's move on to the next question. Alright, so number 3, we are just evaluating a definite integral. So the integral from 1 to 2 over 1 over x squared dx. So this is one of the integrals where rewriting makes it extremely easy to compute, okay? So we know that the power rule for integrals is really easy, so if I can use it here, it would be preferable, okay? So I'm going to rewrite this as an integral from 1 to 2 of x to the -2 dx, okay? Using the reciprocal property of exponents, when you reciprocate an exponent, it negates the power. Alright, so there you have it. Now we can evaluate the integral using the power rule for integral. So it's going to become negative 2x. I'm sorry, it's going to be x to the, let's write this, so I was differentiating instead of integrating. It's going to be x to the negative 2 plus 1 over negative 2 plus 1. Okay? And we're evaluating this from negative 2 plus 1, evaluated from 1 to 2. Okay? So let's simplify this as much as we can before we plug these values in. So it's going to become, you can write this as x to the negative 1 over negative 1, evaluated from 1 to 2, simplified a little bit more. Using the reciprocal property of exponents, I can write this as negative 1 over x. Okay? So we evaluate this from 1 to 2. So we have to be really careful with this integral because we have a negative here. So we have to be careful with that. If you want to avoid making a mistake, you can switch the boundaries and take away this sign, and then makes it somewhat safer. Okay? Alright, so how about we do that? Let's just do that. So I'm going to write this as 1 over x. I took out the minus, and I'm going to reverse the limits of integration 2 to 1. You can use it. You can do it the other way, but I'm just trying to be safe here. So using FTC part 2, we're going to have 1 over, you plug in the upper limit of integration, 1 over 1, minus, and then you plug in the lower limit of integration, 2. What is 1 minus 1 half? 1 minus 1 half is 1 half. Your final answer is C. Okay? So notice if you made a slight mistake with the signs, you would have had a negative 1 half, and then you have a problem. You would have selected this as the answer, which is actually wrong. Alright, so please be really careful when you're evaluating definite integrals with negative signs involved. Alright? Okay, let's move on to number 4. Alright, so number 4, we're told that if f is a continuous function on a closed interval AB and differentiable on the open interval AB, which of the following could be false. So option number 1, option letter A, if you look at option letter A, this is the mean value theorem. F prime of 0 represents the average, okay? So what are the conditions of the mean value theorem? If a function is continuous in a closed interval and differentiable in the open interval, then that C, there has to exist a C that satisfies the conclusion of the mean value theorem. So option A is true. Is always true because these conditions stated here are the prerequisite conditions for the mean value theorem. So A is true. B, option B is known as the Rolle's theorem, which is a special case of the mean value theorem. It's not always the case. The Rolle's theorem holds if and only if f of A is equal to f of B. In that case, this value right here will be equal to 0. Okay? But is that what the initial condition was? Absolutely not. You only told that the function is continuous and differentiable, nothing about A and what f of A and f of B equals, so we know that this is absolutely wrong. Okay, so the Rolle's theorem is a special case, it's not always the case. But if a function is differentiable on a closed interval, and it's differentiable on an open interval and continuous on that same closed interval, then the mean value theorem always applies. Alright? So the answer is going to be option letter B. Alright, now let's move on to question number 5. Here is just a definite integral problem from 0 to x. It's just testing our knowledge of the integration rules of trigonometric functions. Okay? So what's the antiderivative of sine? You have to be really careful here. We're not differentiating, we're integrating. Remember the derivative of sine is negative cosine. So the derivative of sine is positive cosine. That's not what we're doing. We're actually taking the antiderivative. So the antiderivative of sine is negative cosine t. Because when you differentiate cosine, there's a switch in the sign. So when you integrate sine, there's also going to be a switch in the sign also. So the antiderivative of sine t is negative cosine t. We're going to evaluate this from 0 to x. And then using the FTC part 2, we're going to plug in upper and lower limits of integration. Okay, so this is going to become negative cosine. All right, let's be careful with the minus here. Well, how about we do what I told you earlier to do? Because I hate having a minus there. It complicates things. Okay, so I'm going to switch the limits of integration and switch the sign also. Cosine t evaluated from from x to 0. All right. So now plug in the upper limit using FTC part 2, cosine 0 minus the lower limit cosine x. All right. Cosine 0, remember, using your cosine curve, cosine 0 is the max, that's for the maximum, which is 1. So cosine 0 is just 1. 1 minus cosine x. And your answer is option letter E. Okay? So there you have it. Thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking here to get future updates to the next parts of this installment. And please post a comment to let me know what you think about this presentation. More clips can be found on my.com. Thanks again and have a wonderful day.